Okay, this is a demonstration of the MAG-ic Probe software and a walkthrough of all the capabilities and features to show you how to work the software and what it can do. So it obviously works in conjunction with the MAG-ic Probe measuring tool. So when you load the software, you can upload a picture of your instrument, whether it be a guitar or a violin or cello or anything else, mandolin, and make sure that your picture is formatted to show as much of the instrument as possible. That'll give you the highest resolution in order to place measurements on the picture. So we're just going to use this blank violin for now. So first step is I'm going to connect to the actual MAG-ic Probe tool by going to port selection and recalibration at the top menu. Select my serial port. In my case, my MAG-ic Probe is connected to serial port COM90, and when I click on that, you'll see that the green light at the top will light up, and you'll start seeing the on-screen messages for calibration on the screen. So I'm going to go through the calibration procedure. It tells me to attach the ball. I attach the ball onto the probe, and the next step is to remove the ball. That's the calibration procedure, and it should say calibration is succeeded and that it's detected the big ball. Okay, so the probe is now ready to measure. In the top right hand corner you'll see that the green light is now flashing, and when I move the ball on the probe we have some changing readings on the actual screen itself. So I'm now ready to do some measurements on the screen. You'll see that when I move the magnet on the probe, the readings are changing. I'll get to a stable measurement here. So there's a measurement that I'm measuring right now, 2.92 millimeters, 115 mil. This is obviously the metric reading, and this is mils is in thousandths of an inch, being 115 thousandths of an inch right now. There is a free and a hold mode button at the top here, which can be engaged. What this means is that when I'm doing a measurement and I press on the hold mode, no larger measurements will be allowed through to update the display. Only smaller measurements will actually be allowed through. So when I decrease the measurement, it'll hold the lowest value of this. So when I now move the magnet on the probe, nothing will increase. It'll only allow smaller measurements to go through, and I can get back to my normal mode by unclicking the free mode again. That allows you to get the lowest possible measurement at a particular location to make sure that your probe is vertical and that the ball is centered on the probe at the bottom of the instrument. So there are a few ways of actually entering those measurements onto your picture. The most common way is actually to point to the location where you're measuring on the screen, and that's the same location that your probe is on the instrument. So for example, if I was measuring right next to the F-hole right here, I would point to the exact location that I'm measuring, and the current measurement at the top would be entered into this location where I'm pointing to. So when I click the mouse, that location is entered there, and it says 2.92, which is the current location, and you see the dot is where I actually clicked. Now, right now it's only entering the millimeters or the metric value into that location. I can choose to enter the mils value into that location, or even both, by going up to the file menu, settings, and in the measurement tab you will see that the data properties says millimeters and no for units. If I choose to do both and click on units, it'll now display both readings with their units. So when I click on the screen now, it'll say 115 mil and 292 millimeters. That obviously takes up a lot of room on the screen, so you may want to just settle on the measurement that you actually work with, and then you don't even have to display the actual units either. So that can be done by there. Now when I click, I'll just get the 2.92. One other thing that I've added to the software is an ability to actually add an offset to the current measurement. So some users compare the measurements to their favorite other measuring instrument, and if they see a different, they want to actually make both of them the same. So if you feel that the gauge is inaccurate or could use an adjustment in either direction, you can actually change or add an offset to the actual reading at the top. So let's just do that. You can either do it by value or just enter a percentage, and you can choose to whether you're changing the actual mil or millimeter reading. So in this case I'm going to do the millimeters, and let's add a 0.5 offset to the actual reading. So when I click now, you'll see that the millimeters has gone up a little bit, and when I click now, that 0.5 has now been added to the actual reading over there. So again, if you want to add an offset, preferably do it in the measuring range that you'll be measuring. So when you're comparing to some other type of measuring device and you want to set them both the same, do it in the range that you're measuring. So don't do it in the 10 millimeter range if you're measuring a 2 to 3 to 4 millimeter instrument. So I'm just going to remove that offset again. Okay, now our measurement is back to standard. You can delete the last entry by either going to the menu or just pressing Ctrl Z, and you can obviously redo a measurement as well if you've made a mistake. Okay, there are a few ways of, as I said, of entering measurements. The one was just pointing to the actual location, but some people find it a little bit difficult sometimes when holding an instrument and the probe itself to measure, to actually move the mouse to the specific location that you want to measure. So MAG-ic Probe offers you some other methods of entering the measurements without having to point to the specific location on the screen. You can go to File and you can go to the pre-map mode. This adds some options here to the top called Map Location and Map Values. So how this works is that you can actually pre-plan the locations where you're going to be measuring for this particular measuring session. So when you click on Map Location and then click on the screen, it actually starts putting a numerical sequence of dots on the actual picture itself. So you can then pre-plan to say, I want to start measuring here, my next measurement's going to be there, then there, and there, and there, and so forth. And you can just continue placing these dots, which are again pre-planned locations where you're going to be measuring. Once you're ready, of course, you can fill up the whole instrument with pre-planned measuring spaces, and once you're ready to actually measure, you change at the top to map values. What will happen with the map values is that the current reading will be transferred to location number 1 as soon as I click the mouse. Now I don't have to click it anywhere particular on the screen. I can click the mouse anywhere on the screen, and that value will be transferred to location number 1. You'll see 2.9, and every time I click the mouse after that, the current reading will be added to the next sequence of locations. So this is my next reading over there. I click my mouse and that value gets entered in number 2, and then number 3, and so forth as I go about my measurements. And again, if you've made an error, you can press Ctrl Z to remove that. It'll return the location number 8 back to number 8, and then when I press the mouse again, it'll add that measurement to number 8, and then number 9, number 10, and number 11. If you go over that amount, it'll tell you through an error that you cannot measure more than the pre-map values. Okay, so that's the second option of adding measurements to the screen. I give you one more option, which is actually an auto insertion. So this is for those who actually don't have enough hands to even click the mouse, and you want to have a completely automated insertion of the actual values. So I'm just going to delete these values out of the locations again, get back to our numerical sequence, and now if I engage the auto insertion option, you'll see that it brings up a counter on the screen which is starting to count from 5. And so how this works is that when you're ready to measure, you click on start and it'll wait for the probe value to be stable. And so in other words, when I'm moving the probe around the instrument, the value is unstable and it is changing all the time. As soon as I settle on an area and I stop moving, that value should stabilize pretty quickly. And once it is stabilized, the counter will start from 5 and count down 4, 3, 2, 1 and then 0. And then once it reaches 1 or 0, that value will be entered into location number 1. And then I would move to location number 2, which would obviously cause my value to be unstable. The counter will not start until it's stable, and then it'll start again once I reach location number 2 and stabilize the measurement again. So you can adjust the number of counts again by going to File, into the pre-map mode. By going to File, Settings, and then to the General here, and in the pre-map mode here, you can the auto insertion duration, you can increase or decrease that, and you can also vary the variation factor. Now the variation factor is the stability of the probe. If you want to increase that or decrease the stability factor. Okay, so once I start, it'll start this counter if my probe value is stable. You'll see the counter will go down to 3, and then that value will be entered in location number 1 as soon as it's stable. Okay, if I make the probe unstable, as if I'm moving it around, the counter will go back to 5 until it's stable. Once I reach a stable measure, the counter will start again from 5 and go down to 4. So you have to kind of watch your movement and make sure that you're ready at your next location, and then make sure that you wait until the counter drops and that the value is actually entered into the next location. So this will work. Basically, you don't have to actually click anything on the screen. You can just move the probe around and just be ready for the next countdown, and that value will be actually automatically added to the screen. Okay, so those are the 3 ways of adding measurements to the instrument via MAG-ic Probe. Right, so I've added many measurements to this violin. I used the pre-map mode to pre-plan all these dots and then added values to them. These are basically just fictitious values. I don't actually have a violin available, but you'll see the outcome is as expected. So once I've got all my measurements in, or prior to that, if you want to, you can actually change the color of the font by going up to Label Format, select a color. You can change this font into any color that you prefer. For instance, if we go to pink or red or whatever, you would obviously choose the color that's most contrasted to your background. In this case, I found that the blue was a lot better. You can also change the actual font itself, choose a font style and choose a size that you want, bigger or smaller. Smaller will obviously allow you to fit more measurements into the actual picture and be more separated from the neighbors. So once you've got that, you can actually save this image. You can either go to File, save the image and save it as a JPEG file. The measurements will actually be saved with that file. For instance, here I've saved a picture, I've saved this picture, and looking at it in Windows Photo Viewer, all the measurements are actually saved on that file, including the background picture. You can also choose to print the actual file, and as you see, there are some boxes at the bottom where you can enter the name and the date and the version, and then any notes on this particular measurement that you were doing. When you go to print, it'll actually print out with those measurements, with those notes at the bottom. And so this is good for record keeping, to compare to future instruments, or just to keep a record of your instruments that you've made, or catalogued, or what have you. So you can print that out as normal. Right, so as far as the features of the MAG-ic Probe Lite version, the free version that you find on the internet, on the website, those are basically the features that allows you to do up to the MAG-ic Probe Pro. The Pro version of the software allows you to do a lot more, as previously mentioned. So everything basically from here on pertains to the actual Pro version of the software. So the first thing that the Pro version allows you to do is to actually go from here and actually see a color contoured map of these measurements. So where these measurements, being numbers right now, may make sense to you as the builder, it doesn't give you an overall view of your instruments unless you're looking at the actual values and comparing that to a previous plan or something like that. So the Pro version allows you to go through to the color contoured map of the software. So the procedure for doing that is described now. So in the Pro version, you'll actually have an export measurements option, and you can either export these values into a text file, or we can go into the contour application. So to do that, the first thing you're going to do is to define layers. So what the layers are is to define the outline of your instrument firstly, and then also to define any cutouts or areas that you cannot measure because of obstructions. That may be a fretboard, that may be a bridge assembly or something like that. In this case, the F-holes are the cutouts to the instruments, and there may be, as I said, another assembly here, which is a fretboard or something like that, that you also have to mark. That's not going to be contoured according to your measurements. So that's what we're going to do right now. So when you've clicked on define layers, at the bottom of the picture here you'll see some extra options, and you will firstly choose to define your layers in mils or millimeters. This should be the same as what you've defined to do your measurements on the instruments, which you'll remember is in millimeters. And you're going to define layers, anything up to 8 different layers. Now these have nothing to do with your actual plate itself that you've measured. So in this case we measured the top plate of the instrument. So these layers have nothing to do with that top plate except to define the outline. So layer 1 will always be the actual outline of the instrument. Hopefully before you assemble the instrument you did some measurements on that plate, and you will know the thickness of the actual outline of the instrument. So with a violin you can probably measure that again with a vernier or a caliper, but layer 1 will be your outline. Layer 2 will be any cutouts that you have in the instrument, and you can separate the cutouts by making them different layers. So it doesn't really matter what layers they are. Layer 2, 3, 4, 5, 6, 7, 8 will be any layers that you want to enter on the inside of the instrument that should not be mapped in the contour application. So the first thing we're going to do is layer 1 is to define the outline of the instrument, and you can choose a default thickness for the outline. On most instruments the actual outline of the instrument is the same thickness all the way around, so by choosing a global value that makes it easier. So in this case let's choose a global value of say 4 millimeters, that we're going to say that the outline is consistently 4 millimeters around, and of course we can edit certain points of that as well, as I'll show you in a second. So the layer color here will be yellow for the outline. We can choose to make that let's say red if we like. That'll be the layer color for global value or outline number 1. Alright, and so what you're going to do is to go on the outline of the instrument and click, and basically it'll put a dot with the value 4 next to it, which means 4 millimeters. And you can put these dots as accurately or inaccurately as you like, and as close as you like together, especially when it comes to the curve of an instrument. Basically, it's going to draw a line between each point to define the outline of your instrument. So the closer you make them around a curve, the better curve you're going to get, but that's totally up to you how accurate you want to be on your instrument. Right, so once you've got the grid set up like you prefer it, with your grid contours and your color contours, obviously the aim is to get the lines as rounded as possible, get enough definition between the lines as you need, and to get your colors to be as gradient as possible, instead of being chunks of yellow and green and blue, to be flowing into each other so that you can see the map. So however you prefer to see the colors, some people prefer cooler colors like yellows and blues and greens, but if you prefer to see it in darker colors, let me do a blue for the mid color, a darker blue, and a red for the end color. So if you prefer to see the warmer colors like that, you can adjust this in any way that you want to see it. Maybe the yellow here is not a good idea. If you like to see something even warmer than that, type in a green value there and just apply it. So whichever way you like to view this, you can view it so that you can see the distinction between your thicknesses and your gradations as far as it goes onto the edge, and of course with your cutouts included. So this is the MAG-ic Contour part of the application, which is part of MAG-ic Probe Pro. And again, you can preview this, you can print this file, set it up any way that you like to print it out and so forth, and again, you can choose to have your measurements on the page, or even take your measurements out and just see your color contours and the actual colors as such. And you can print this out, you can save it. So a much better way of record keeping for your instruments. You can instantly compare one instrument to the other and see the color gradations, and as you modify your instrument, perhaps if you take this to the sander and keep on working on the instrument, you can compare color maps as to how the changes that you make to the instrument actually take effect, and what you end up with finally. So turning this grid of almost meaningless numbers, unless you're comparing two together, into the color gradation map, is what MAG-ic Probe Pro is all about. So hopefully you enjoy this feature that's been added to the system, to MAG-ic Probe, and let me know if you have any questions.